What if your AI could take one goal, gather information, compare options, and stop with a clear recommendation? That is the basic idea behind an AI agent. In this episode, we'll make that idea practical, not magical, so you know exactly what people mean when they say agent.
A simple beginner definition is this: an AI agent is software that works toward a goal by choosing actions and checking the results. Think of it like a very organized assistant with a checklist. You give it a task, it does one useful step, looks at what changed, and then decides whether another step is needed. That is the key idea. It is not about sounding smart. It is about making progress in a controlled way. Chatbots, workflows, and agents can all use tools and multiple steps. The distinction we will focus on is that an agent uses a control process that considers the current information and each action's result before choosing what happens next. In this series, we will build that idea in Python piece by piece, so the logic stays easy to follow.
Chatbots and agents can overlap, so this is not a strict either-or. A chatbot is usually organized around conversation. You ask something, it responds, and the exchange continues. An agent is organized around completing a task through repeated decisions. It may still talk to you, ask questions, or call tools, but those actions support a larger job. A chatbot might use a tool once to answer a question. An agent keeps evaluating whether it should use another tool, ask for more input, or stop. For example, a travel chatbot might explain train routes or compare cities in general. An AI travel agent might compare trains against your budget, departure time, and arrival time, then produce a recommendation. So the distinction is not chatbot versus tools. It is whether the system is organized to evaluate progress and choose the next step toward a goal.
The easiest mental model is observe, decide, act. Observe means collecting the current situation. Decide means picking the next step. Act means doing it. Then the system checks the result and repeats the cycle. A thermostat is not an AI agent, but it demonstrates a similar control idea. It reads the temperature, compares it with a target, and turns the heating on or off. This loop is only a beginner model, not the only way to build agents. Real systems can use fixed workflows, routers, or event-driven code. The useful idea is that the system is structured to move toward a goal. And every loop needs a stopping rule. The loop ends when the goal is met, a step limit is reached, or a person must approve the next move.
Let's make that concrete with a travel example. Say the goal is to find the cheapest train from Berlin to Hamburg tomorrow morning that arrives before noon and costs less than $60. First, the agent sees the user's request: destination, date, and those two constraints. Next, it calls a train lookup tool with that input. The tool returns several candidate trips. One is cheapest but arrives late, one is fastest but costs more, and one is a backup with a transfer. The agent removes any trips that arrive after noon or cost more than $60. From the remaining valid options, it selects the cheapest one. If nothing fits, it asks whether you want to widen the time window or increase the budget. Then it stops once it has a valid recommendation or once it needs new instructions.
This is where boundaries matter. An agent may be allowed to read data automatically, but not to spend money, send an email, or book a ticket without confirmation. That is not a weakness. It is how we keep the system safe and predictable. In real products, developers use permissions, approval steps, and step limits to box the agent in. Those limits matter because even a useful agent can make the wrong move if the goal is unclear, the data is incomplete, or the tool returns something unexpected. So when you design one, ask two questions. What can it do on its own? And which actions require explicit human approval? That boundary is part of the design, not an afterthought. Let's recap. An AI agent starts with a goal, observes the available information, chooses an action, checks the result, and decides whether to continue or stop. A model may help select the action. Tools let it interact with outside systems, and rules define what it may do. The important idea is controlled progress toward a goal, not unlimited autonomy. In Part 2, we'll turn this mental model into an architecture. We'll map the model, instructions, tools, state, control loop, and approval boundaries before writing any code. You'll see how information moves through the system, where each decision happens, and how the pieces connect. Once that design is clear, building the Python version becomes much easier.